These are the Chapter 6 review notes. These are parallelogram attributes. In a parallelogram, these 5 attributes will be there. Both pairs of opposite sides are parallel, so you have to use the words both pairs, opposite sides, and then there's the symbolic for parallel. Both pairs of opposite sides are congruent. There's the symbolic for congruent. Both pairs of opposite angles are congruent. Again, symbolic for congruent. The diagonals also bisect each other, and consecutive angles are supplementary. And supplementary means that the 2 angles, when added together, will equal 180 degrees. Okay, there are special quadrilaterals. A parallelogram is a quadrilateral. We've already gone through its attributes. But there are other special quadrilaterals besides the parallelogram. As we know, the parallelogram has 2 pairs of opposite parallel sides, 2 pairs of opposite congruent sides, 2 pair of opposite congruent angles. The diagonals bisect one another, and the consecutive angles are supplementary. So we know all of that about the parallelogram. Now, special types of parallelograms are rectangles, rhombuses, and squares. Rectangles, rhombuses, and squares have all the same attributes as the parallelogram, all of the 5 given above. In addition to that, they have some special ones. For instance, the rectangle has 4 right angles, and its diagonals are congruent. So not only do the diagonals bisect each other, but they are also congruent. For a rhombus, it has 4 congruent sides, and the diagonals not only do they bisect each other, but they are perpendicular to one another, so they form a 90-degree angle. The square has all of the attributes of the parallelogram, the rectangle, and the rhombus. So a square has 4 right angles like the rectangle, and it has 4 congruent sides like the rhombus. And so based on that, we can note that some squares are always rectangles, but rectangles are only sometimes squares. Squares are always rhombuses, but rhombuses are only sometimes squares. This is the type of deductive reasoning one can take from this flow chart of special quadrilaterals. Now moving on to trapezoids. A trapezoid is a quadrilateral. It has 4 sides and angles. However, it only has 2 parallel sides, meaning 1 pair of parallel sides. So again, a trapezoid has 1 pair of parallel sides versus a parallelogram that has 2 pair of parallel sides. Okay, then you have special kinds of trapezoids, and that special kind of trapezoid is the isosceles trapezoid. And in the isosceles trapezoid, you can see that the legs, these are the legs, these slanted things are congruent. The base angles are congruent, so this angle is congruent to this angle because that's a pair of base angles, and this pair of base angles, the one with the double lines, are also congruent. The other thing you can deduce from this, from the same side interior angles theorem, is that the base angles on the same side will be 180 degrees, will be supplementary because of the same side interior angles theorem. We'll address that just slightly later when we look at how to figure out angles of an isosceles trapezoid versus a non-isosceles trapezoid. So what we're going to address next is going to be midpoint of a trapezoid, and then we're going to just look at the angles of isosceles trapezoids. So the next slide we'll be looking at will be trapezoids. All right, we're going to look at the angles of a trapezoid. Looking at trapezoid A, B, C, D, the temptation is to say, oh, this is isosceles, when in fact there's been no information given that it's isosceles. So what we have to assume then is that it's not isosceles, so then we have to use the idea that these 2 are parallel lines. Let's go ahead and extend these lines. So I'll extend these lines. That's BC is parallel, AD is parallel, and then CD right here is a transversal, which means that you now have 2 parallel lines cut by a transversal. So this angle 60 degrees and this angle C will be supplementary. Well, in order to make it supplementary, it would be 180 120 degrees. So measure of angle C is 120 degrees because 180 degrees minus 60 degrees equals 120 degrees. On the other side, you again have the same parallel lines, and we're going to write that they're parallel. So one of the things we're deducing is that BC, and we're talking about the line, is parallel to AD, and they are being cut by the transversal CD in the first situation, and they're being cut by the transversal AB. And so then we would have, this is 110, and so angle A is going to be 70 degrees, is 180 degrees minus 110 degrees is 70 degrees. So that is not, even though it looks like it possibly could be an isosceles trapezoid, it is not, because you're not given that information. Now, in an isosceles trapezoid, you know that they'll be congruent legs. So again, one pair of parallel sides. There will be congruent legs, which tells you when there are congruent legs that the base angles will be congruent. So angle M's base, the base angle for angle M is angle P, so that's 55 degrees. And then the base angle for angle O at 125 degrees is N, so the measure of angle N is also 125 degrees. All right, now, you can also know that a triangle, an isosceles triangle, let's go ahead and draw another one. You could also know that this trapezoid was isosceles by knowing that this pair of base angles are going to be are congruent. Therefore, these legs have to be congruent, and this other pair of base angles would be congruent. So this would also be an isosceles trapezoid. Okay, so moving along now to the midpoint, or mid-segment, excuse me, of a trapezoid. Okay, the mid-segment of a trapezoid intersects each of the legs right at their midpoint. So this piece would be congruent to this piece, and this piece would be congruent to this piece. The formula for the mid-segment is this. If you're given both of the bases, so if this is 8 and this is 12, then the mid-segment would be the middle, in the middle of that, the average or the median of that. So you would take your segment of 8 plus your segment of 12, those are your bases, and you would divide it by 2. That's going to give you your mid-segment. So 8 plus 12 is 20, divided by 2 equals 10. And so the mid-segment of this particular trapezoid is 10. Now, finding the mid-segment of a trapezoid works on any trapezoid, those that are not isosceles and those that would be isosceles. So in this case, we're going to change the parameters a little bit, and I'm going to give you one of the bases. We'll say that this is 4, but instead of giving you the other base, I'm going to give you what the mid-segment is, which is 10. Now we know that this segment is congruent to this segment, and these two segments are congruent because the mid-segment cuts or bisects each of the legs. It hits at their midpoint. And so what I need to know is, I would need to know what divided by 2 would give me 10. Well, that would be 20, which means that 4 plus what is 20? Well, that's 16. So we know this side is going to be 16, but let's go through the actual algebra to find that. So we'd say 4 plus something, we'll use x, divided by 2 equals 10. The opposite of division is multiplication. So we're going to go ahead and change colors so you can see where I'm multiplying both sides by 2. If you want to put a 1 under this, you can. These cancel and become 1. You're left with 4 plus x equaling 10 times 2, which is 20. Subtract 4 from both sides. 4 minus 4 is 0, so you're left with x. 20 minus 4 is 16, which was our expectation. So this unknown side is 16. Now, by far one of the more difficult problems for students is when you're finding the angles of trapezoids that are non-isosceles. And so I'm going to go ahead and put the problem from page 346, which is your chapter 6 test review, and number 13. I would like you to try it on your own using this skill that we learned right here, this finding the angles of trapezoids when they're not isosceles, and then turn the recording back on when you're finished. So I'm going to go ahead and have you go to the next page. We're going to write number 13 down. Once you've got it on your paper, go ahead and solve it, then you'll turn off the recording, or you'll turn off the recording to solve it, and then you turn it back on to check your answer. Okay, this is the figure from page 346, number 13. You can see that angle P is 68 degrees, angle R is 122 degrees. This is not an isosceles trapezoid. You need to find the measure of angle S, and you need to find the measure of angle Q. Would you go ahead and shut the recording off? Once you've done this, then turn it back on to check your work. Okay, so this is not an isosceles trapezoid, and we first have to ascertain that PQ and SR are parallel, and they are. Lines PQ and SR are parallel. I've extended those lines. I'm going to look first at this transversal QR that's cutting the two parallel lines. We know the angle 122 degrees, so angle Q is going to be supplementary to that. So 180 minus 122 is angle Q's measure, which is 58 degrees. Okay, parallel lines PQ and SR are also being cut by the transversal PS, and we know that the measure of angle P is 68 degrees. S is supplementary to that, so 180 degrees minus 68 degrees is going to be 112 degrees. And we know those because angle Q and angle R, these two angles, are same side interior angles. And then on this side, angles P and S are also same side interior angles, meaning they equal 180 degrees. And that's the same side interior angle theorem we used. Okay, this completes the chapter 6 chapter test review.